Welcome back to my channel, Math and Language, and we're going to discuss how to solve growth and decay. Let's start with the formula. So we have y is equal to a times the quantity 1 plus minus r to the t power. So if it's growth, that will be plus. If it's decay, that will be minus. So for the variables, y is equal to the final amount, a is the initial amount, and we have the growth or decay factor that will be 1 plus minus r. Just in case in the question you're asked to find the decay factor or growth factor, and r will be the rate and t will be the time. So let's start with the growth. So let's start with the example number 1. What if you are asked to find the final amount? So let's have the example. Teddy owns a chain of fast food restaurants that operated 100 stores in 2000. If the rate of increase is 15% annually, how many stores does the restaurant operate in 2010? So y is equal to the final amount, a is equal to 100, r is equal to 15%, t will be 2010 minus 2000. So let's change the percent to decimal form. That will be 0.15. So again, A is 100 because it started around 100 stores in 2000. So the final amount, of course, that will be the future. So moving on, time will be just subtract it, 2010 minus 2000. That will be 10 years. Okay, next one. Place a formula and substitute the values. So we have y is equal to 100 times the quantity 1 plus 0.15 to the 10th power. So simplify that one, 1 plus 0.15, 1.15, and 1.15 to the 10th power, that will be 4.045, and so on. Multiply by 100, you will have this kind of answer. Now, since we are asked to find how many stores, so let's just round it up to the whole number, whole number. So 405 stores is the answer. Example number 2, what if we are asked to find the initial amount? So let's have the problem. Jesse bought a new house in 2010. The value of the house increases 15% each year. If the price of the house is $300,000 in 2018, how much did he pay for it in 2010? So the starting bought a new house in 2010. We don't know how much was it, but in 2018 it's $300,000. So we know that this is the final amount. So y is equal to $300,000, the final amount. We are asked to find for the initial amount. R is 15%, and time, just subtract the years 2018 minus 2010. Let's change the rate to decimal form. That will be 0.15. And time, 2018 minus 2010, that will be 8 years. Let's place the formula and substitute the values. So 300,000 is equal to A times the quantity 1 plus 0.15 to the 8th power. Simplify 1 plus 0.15, that will be, or you can just divide both sides by 1 plus 0.15 to the 8th power. And in your calculator, you will get an answer of this one, 90,070.23215. Since we're talking about money, so we just take 2 decimal points. So the answer will be 90,070.223. So again, this is in dollars, as the unit is in dollars. Next one. What if we are asked to find the rate? The value of the bond that was bought in 2005 was $100. It appreciated annually up to $1,000 in 2018. Now, what is the rate of increase per year? So let's have the given y is equal to 1,000, a is equal to 100, and r is equal to rate. T will be 2018 minus 2005. Now to find out years, so again, just subtract it, 2018 minus 2005, that will be 13. Now let's place the formula and substitute the values. So 1,000 is equal to 100 times the quantity 1 plus r to the 13th power. Next one, divide both sides by 100, and we have 10 in at the left side. Yep, and for the right side, we only have 1 plus r to the 13 power. To get the value of r, let's have the 13th root of both sides. Now, the reason why is we must eliminate this exponent, 13 here. So you will get an answer like this. Now, to find the value of r, just subtract 1 to both sides, and you will get like this. So input it in your calculator, the 13th root of 10 and minus 1, you will get this one, 0 0.19, 0 0.19377664617, and you will just get to 4 decimal points, 0 0.1938. And to change it to percent, just multiply it by 100 and add the percent sign, 19.38%. Next one, what if we are asked to find time? A sample contains 10 counts of bacteria. The bacteria multiplies at a rate of 50% every hour. How long will it take for the sample to contain 2,000 counts of bacteria? So it started around 10 counts. Now we want to know how long will it take for it to become 2,000 if the rate is 50% every hour. Let's place a given. Y is equal to 2,000, A is equal to 10, R is equal to 50%, T will be time. So change the 50% to decimal form, that will be 0.5. And place a formula, Y is equal to, yes, A times the quantity 1 plus R to the T power. Substitute the values, and we have 2,000 here at the left side. And to the right side, we have 10 times the quantity 1 plus 0.5 to the T power. Simplify it further. 1 plus 0.5 is 1.5. And I divided both sides by 10, so that will become 200 at the left side. Now, remember your properties of logarithms. If you want to find the value of the exponent, you just have to put logs here. The log of 200 is equal to log of the quantity 1.5 to the T power. I also have a video about how to solve logarithmic equations using properties of logarithms. I'll put it in the description box below. Now, since we already have logs here, we can apply the power rule, and the T will be put here. Now, since the T is already here, there's no more exponent here. T is equal to log of 200 over log of 1.5. Now, you have to use a calculator with this one. So that will be log of 200 over log of 1.5, and you will get an answer of 13.06725847, or you can just round it up to just 2 decimal points. That will be 13.07 hours. So back to the question, how long will it take for the sample to contain 2,000 counts of bacteria? That will be 13.07 hours. Alright, so let's move on to the next one, decay. So for decay, we're going to use the minus sign here, not the plus sign. So let's have the first example. What if we are asked to find the final amount? So let's read the problem. A computer valued $6,500 depreciates at the rate of 14.3% per year. Find the value of the computer after 3 years. So we have y is equal to the final amount because we want to know the value of the computer after it depreciates after 3 years, and A is 6,500, that's the initial amount, R is 14.3%, and T will be 3 years. Okay, moving on, since we have to change the rate to decimal form, that will be 0.143. Next one. Let's place a formula, and y is equal to A times the quantity 1 minus R to the T power. Moving on, let's substitute the values. We have y is equal to 6,500 times the quantity 1 minus 0.143 to the third power. Now simplify the values inside the quantity. That will be 0.857. Now, next one, we just have to cube it first, and you will get an answer of 0.6294229,793. So as much as possible. I didn't round it up. So if you're in the middle of the computation, if it's not the final answer, don't round it up or round it down. Don't make an estimate first. So next one, 6 5 times this number, you will get an answer of 4091.2481545. And since we're talking about money, or the price of something or cost, you just have to round it up for two decimal places to two decimal places. So the final answer will be $4,091.25. Alright, so let's move on to the next example. What if we are asked to find the initial amount? So let's read the problem. The bacteria count decreases by 5% each hour in the sample. The current count is 2,000. What was the bacteria count 3 hours ago? So y is equal to 2,000. Now you're asking, why is the value of y 2,000? Because, again, we are asked to find the bacteria count 3 hours ago. The initial amount is also the past amount. Okay? So, next one. Since we already have the given, let's change the rate to percent. Sorry, let's change the rate, the percent, to decimal form. So 5%, that will be 0.05. And place the formula. Y is equal to a times the quantity 1 minus r to the t power. Let's please substitute the values. So that will be 2000 is equal to a times the quantity 1 minus 0.05 to the third power. And let's simplify it further. 0.95 here. Now, cube it. So that will be 0.857375. Divide both sides by 0.857375. And you will get an answer of 2,332.7015 and so on. But since we are asking about the count, so the final answer will be 2,333. So these, the number of bacteria 3 hours ago was 2,333, approximately, because this is the more accurate answer, but we have to round it up. The next one, example number 3, we are asked to find the rate. The population of the rhinoceros or rhinos is declining from 10,000 to 200 from the year 2010 to 2020 respectively. What is the rate of decline per year? So y is equal to 200 and a is equal to 10,000. R will be is equal to the rate. T is equal to 2020 minus 2010. So to find that number of years, just subtract it. That will be 10 years. Now, let's place the formula and substitute the values. We have 200 is equal to 10,000 times the quantity 1 minus r to the 10 power. Divide both sides by 10,000, you will get 0.02 here. Is equal to 1 minus r to the 10 power. To simplify that one, we must remove the exponent by getting the 10th root of both sides. So 10th root of 0.02 is equal to the 10th root of this quantity or value. Now, next one. So I didn't get it the value of this one first, so this one will be removed, and you will get just 1 minus r here. To find the value of r, okay, subtract both sides by -1, and you have negative r here. Now, the 10th root of 0.02 and minus 1, that will be negative 0.3237, and so on. So just round it up. Now to get rid of the negative sign, just multiply both sides by -1, or multiply both sides, or divide both sides by -1. Next one, that will be 0.3238 is equal to r. Now, since we're talking about the rate, talking about percent, so we just have to multiply it by 100, then add the percent sign, and you will get 32.38%. So what is the rate of decline per year of the rhinoceros or rhinos from 2010 to 2020? That will be 32.38%. Let's move on to the last example. What if we are asked to find the time in the decay problem? You drink a beverage with 120 milligrams of caffeine. Each hour, the caffeine in your system decreases by about 12%. How long until you have 10 milligrams of caffeine? So let's have the problem. So again, take note of the word decrease. So it means decay. So y is equal to 10 milligrams. And guess how long until you have? That will be the final amount. A will be 120 milligrams. That's the initial. R will be 12%, and T will be time. We're asked to find for the time. So change 12% to decimal form. That will be 0.12. And let's have the formula. Now substitute the values. You have 10 is equal to 120 times the quantity 1 minus 0.12 to the t power. Next, divide both sides by 120 and you will get an answer of 0.083. Repeating decimal is equal to 0.88. Just answer this one. 1 minus 0.12. Now, remember your properties of logarithm. We have to, if there's an exponent here and you want to find the value of the exponent, you have to add log here. Logarithm. So log 0.083, repeating decimal, is equal to log of the quantity 0.88 to the t power. Now, I'll also have videos about how to solve logarithmic equations using the properties of logarithms. I'll place it or post the link in the description box below. So remember your power rule of logarithms. The t here will be placed here at the left side of the log. So there will be no exponent. So you can find the value of t. Now, algebraically, you just divide both sides by log of 0.88 and use your calculator. You will get an answer like this one. Or the answer will be 19.44. So how long until you have 10 milligrams of caffeine? So our unit is in hours, so that will be 19.44 hours. And that's the end of the lesson on how to solve growth and decay problems. If you would like to comment or suggest another math and language video, please comment down below. And if you have problems with your assignments, I'll do my best to answer it. As comment also down below. And I have a Facebook page. I would really appreciate if you could follow it. It's in the description box also. And again, this is James, your math and language instructor. Please like and subscribe and also click the bell notification so you will be updated on my future videos about math and language. Thank you and goodbye.